Hi folks, this is the video tutorial for homework 1, lab 52, which is meeting on Fridays 1:30 p.m. to 4:20 p.m. I've given two problems. These two problems, they look very similar as far as the geometry is concerned. They are the same actually, but the loading is different. I've asked you only to submit problem number 2. Now let's look at problem number 2. So we have a shaft here which is 10 inches long. This diameter is 0.5 or 1 inch. Diameter is 1 inch. And there's an embossment here, and it has a fillet. The fillet radius is uh, the fillet radius is uh, point 0.1, and I just noticed that this is the geometry that you've got. So that figure should actually be down here too, which I forgot, but that's fine. So uh, let's go ahead and use the geometry, this geometry, and kind of ignore that because these are the same thing. Now there's a few things you have to do. It says make sure that at these two edges, there are forces acting, a downward force of 100 pounds on that edge, and an upward force of 100 pounds on this edge, okay? And the question is, are there any planes of symmetry? The answer is no, there are no planes of symmetry here. Now, when you look at this end is clamped, by the way. When you look at the problem 1, where you're applying a pressure on the face A, B, C, D, then there are two planes of symmetry. One is parallel to the XZ, the other one parallel to the XY. So first thing I'm going to do is I'm going to do this problem for you without any planes of symmetry, and then solve it, and that's the one that you have to upload, and then you're going to come and then I'm going to come and do this problem for you. Okay, so let's go ahead. First thing I'm going to do is start a part file. Do not start with product we're going to do later on when you have an assembly. So we can give this thing a name. Part 1 is fine, but I can call it, for example, well, let's keep it like that. That's fine. Okay. Immediately I'm going to save it. File, save management, save as. On my desktop, where is this? Desktop, I'm going to create a folder, and the name of the folder is going to be homework 1, lab 2, lab 52, lab 52, lab 52. I think I have another one for lab 51. Yeah, lab 51. Okay. Homework 1. Okay, that's good. So what's going to happen is uh, I created a folder there, and now I'm going to save this thing in that folder. But the name of it, I'm going to call homework 1. This is the name of that file, lab 52, problem 2, and then my name or your name, because this is how you're going to submit your work in Blackboard. Okay, so good. Notice that I have a folder on the desktop, which is right here, homework 1, lab 52, and in it I I saved this part. I haven't even made it, but I'm going to save it. Okay, good. Let's go back here. Now, because there is no planes of symmetry, I don't have to, make any cuts here. So I'm going to draw this thing on anywhere on this, what was that, YZ plane. I will draw a circle right there, okay? And the radius of that circle is 0.5, following the instruction given to you on the homework sheet. Exit, and then we're going to pad this thing by 10 inches. And let me remind you, if you don't know how to set units, tools, options, parameters and measures, and then you can change the length to inches, force to pound, and pressure, which is the stress, unit of stress, right here to PSI. Okay, good. Now, the instruction here for you, the instruction here is to draw a rectangle like that on that face. Now to draw that, if it would have been easier if I put this initial circle right at the origin, but on purpose I didn't do that. So I'm going to need a point here. The center of this circle, the easiest way of getting it is point and the point by circle and sphere center. Select that edge, so it puts a point there so we can see where the center of that thing is later on. So on that face, I will sketch. Okay, now I want to draw that rectangle, rectangle with a center specified. So notice that there's different ways of doing this thing. For now, I'm not going to insist that this be on that point. So somewhere there, I'm going to make a rectangle like this. Now, I want to make sure that the center of this rectangle, see that there's a center here. There's a center here. I want it to be coincident with this. So select the center. If I can get it right there, see there's a little orange dot. I think there's a little orange dot there. Control that point, and this thing is constrained, define the dialog box, make it coincident. Okay, so it makes that center of that rectangle coincident with that reference point that I created. Now I'm going to put some dimensions. So this dimension is 1.5 according to the sheet, homework sheet. This one is 0.315, 0.315. There are a zillion different ways of doing these problems as far as geometry is concerned. So if I had to do this problem, I would not do it this way. I would make sure that the original circle that I drew was actually at the origin of that sketch plane. But I didn't do it like that. Okay, and then we're going to pad this by 0.5. Good. And then we have to put some fillets here. So edge fillet on this edge and turn it around on that edge. And I think I said 0.1, the fillet radius. Good. And this is a terrible design because here I have a sharp corner. This is a disaster. In fact, the biggest stress probably is going to be in that corner. It would be in that corner. Okay. Now save everything. Now let us apply material properties. In the problem statement, it says it's steel. Where's steel on the part, and we say OK. If you want to change the properties, double click on it, select the analysis, and you can change it. But I don't want to change it. I'm going to use the default properties. And that's pretty much it as far as the part is concerned. So save everything. Now we're going to go to generative structure analysis. Okay, so what CATIA does, it measures it with element that size. That's a disaster. It's too big. So I'm going to make this thing 0.25. Point, point, yeah, okay, point 0.5. I didn't give any instruction on how small or big this thing is. On the test, midterm, just use the default value. And if it says go and refine the mesh somewhere, then follow the instruction. And I'm going to use parabolic. Okay, let's look at the mesh, right click, mesh visualization. There we are. This is terrible. Let's make it smaller. So maybe 0.3. Right click, mesh visualization. That's more civilized. Okay, but look at the problem statement. It says, make sure that the mesh around the fillet is finer than the rest of the part. Okay, so, and that says here too. So we go here. First thing that you need to do is deactivate this mesh. Don't delete it, deactivate it. Okay, you can delete it if you want. Change the rendering so that you can see better, right there. Okay, now, if you look at the model manager, this toolbar which has the traffic light here, the second icon, there's a bunch of things in it. The middle one says local mesh size. So what you can do is you can go and select places where you want to find your mesh. See, right there. See that little green dot there? Size 0.05, okay? You can change that, of course. And then this other side, and then say okay. So this is a lot smaller than the one that's out there. And if you want to make sure, right click mesh visualization, or you can say activate this. Either way, it doesn't matter, same thing. You see this? So much smaller? Okay, very good. And deactivate it now. Now, by the way, notice that you have saved the part before we got in there. However, the analysis is not saved. So file, save management, see the analysis is not saved. Save as in that same folder. Okay, so let me give it some name. Homework 1, problem problem 2, or maybe lab 52, problem 2, problem 2, and your name or my name. It doesn't matter. You can call this thing analysis 1. If it confuses you, you can either get rid of that 1 or put a 2 there to remind you that it's for problem 2. This has it's just a label. There's nothing to do. The identifier is right there. You say okay, and that's going to be saved. If you look at your folder, you not only have your part, you also have your analysis. And you have to upload both of these so that the marker can grade these for the homework or for the test. If you just send the bottom one or the top one, analysis without the part, or part without the analysis, you won't be able to mark it for you. Okay. Now, this is great. What do we know? At the end, this edge is clamped. Okay. And we are told that there is 100 pound in this edge down, 100 pound on this edge up. This is why there's no plane of symmetry. You can see that. So you select it, select this edge, minus 100 down. You can see that. Select this edge, plus 100 up. Incidentally, if these were both down, this was also up there and down, then there would be a plane of symmetry. Okay, but not here. That's pretty much it. So save everything. All I do is click on the floppy, and instead of going there and doing file save management, once you have already saved it, you click on this and it's going to overwrite the other one. Run it right there. See that? Compute all. There we are. Look at the deformation. This is a torsion problem. You can see that. You can see that. If you want numbers, right there on the numbers, change the rendering to average ISO, make it look nicer, and change the material shade rendering to material shading. You can see that. If you want to see the elements here, by the way, you go to the very bottom with a question mark. It just puts the elements in there too. If you want to see the von Mises stress, right there, and notice that for this problem, these are the vulnerable places, because if you have a concentrated force, right below the concentrated force, you have infinite stress. If you have an edge load, right below the edge load, you have infinite stress. Okay, that's really what I meant. Okay, so this is why it's not a good idea to use concentrated force or edge load, because of what you can see. Okay, uh, fine. Now, what you have to update is two things: the part and this analysis. Okay. So now I'm going to close this. This is my original part that I made, and I want to solve problem number 2. Problem number 1. Problem number 1, the difference is that you're applying a pressure on this face ABCD. When you think about it, use your common sense, look at this drawing, visualize this thing. This has two planes of symmetry. One is you cut along the x-axis. In other words, a plane which is parallel to the xz plane, right there. You cut it like that. And then you cut it with the xy plane, parallel to the xy plane. So all you need is really 1/4 of that. Now, there's two ways of doing it. Either you could have created the quarter model to begin with, or you create this and start cutting it. So here's what we're going to do. This is the part 1. First of all, save it as a different part. So file, save management. This part 1, save as. Same folder though, so I'll call it part 2, because I don't want to mess up my first part. Okay, this is problem 1. Problem 1. actually this is what you need to change. That one is really irrelevant. You can keep it as part one. It doesn't matter because you have changed the name here. Okay, so I mean, look, I'll call it part. How about that? Okay, this is a different thing from the one up there. Okay. You say okay, and you say okay. Now, so any changes that you make here is not going to affect the other one. All right, because it's saved as a different part. Now, what I want to do is I want to cut this thing with a plane parallel to the xz and a plane parallel to the xy, and I don't have it. If I had drawn the circle right at the center, right at the origin of the sketch plane, then I could have used directly xz and xy. And that's the way I would have done the problem myself. But I want to show you different ways of doing things. So here's the situation. So offset, create a plane, offset from that top plane, but uh, flip the direction by half this length, and that was 0.75. The entire thing was 1.5, so that's 0.75 there. So I can cut it with this, and it's going to give you half of that. And you also want to create a plane in the vertical direction. Now, here's the way I'm going to create the vertical plane. So plane. So I'm going to use a different method through, let's see now, the different ways of doing it, but the one that I'm going to do is through, how about parallel through a point, parallel through a point. It says parallel to what? Okay, it's parallel to the, let's see now, parallel to the XZ, okay, parallel to the xz like that. And through what point? Through this point. See that? It created a plane which is parallel to the xz and through that point, and that's exactly what I want. Okay, so let's start cutting it. The cutting is in the, you need a saw, split, okay? So splitting element, this is the plane. Arrow down means you keep the bottom, arrow up means you keep the top. It really doesn't matter, I'll use the top. And then again, split with this guy. Doesn't matter which side you pick. There we are. Okay. All right. So this is what I want. Okay. So save it. Copy. And now you're going to go to the generative structure analysis. Okay. Remember, we made this thing smaller, so I can't remember where it was. I'll make it 0.3. Okay. And to get full mark, you want to finer mesh around this fillet. The other fillet is gone. There's nothing there. Okay. So where was that thing? It's right there. See this? Local mesh size on that fillet. 0.05. See that? How much this is smaller than that? Say okay. And if you want to look at your mesh, put the cursor on nodes and element, right click mesh visualization. There we are. Finer here. Something there. And deactivate. Deactivate the mesh. With the mesh in front of you, there's nothing you can do. Okay, so this end is clamped, and these are planes of symmetry that I have introduced. Now, what that means is that the points on this plane and that plane cannot move perpendicular to it. Planes of symmetry. Think about it, and that is called used to call it roller. It's called surface slider. So this one and the bottom one, you can do that separately if you want to, but you can do it simultaneously. Okay, so these are basically rollers. Now, what about the load? You go to the load, it says 400 psi on that face ABCD. But I took only a quarter of that, so I put 100 psi on that little piece that we have. And then you're going to lose a lot of points on the midterm. Because if this was 400 pounds and you took a quarter of that, on that quarter, one quarter of 400 is going to go 100. But this is pressure. Pressure doesn't matter how many times you divide this thing. The pressure is still 400 psi. So do not divide this thing by 4 because you took one quarter of that. But if it was a force, then you divide it by 4. Okay, so let's go back here. Where is the pressure? The pressure is right there on that face. Now, 400 psi, that's correct because I did it for lab 51, so it's correct number. And a positive means that compressive, positive pressure means compression, like that. If I make it negative, it's tensile. I don't want a tensile, I want a compression. Change it back. Good. And we are done. This is it. Now, the analysis you have to save. So file, save file, save management. This analysis I'm going to save as. Now already there is this guy there. Remember this was analysis uh, problem 2. Now this one I'm going to make it problem 1 because first I did problem 2. And this last thing, it really doesn't matter. You can leave it alone. You don't have to. You already changed the name here. This is just an indicator, okay? If you want, you can put a 1 because you said this is problem 1. You put a 1. You can put a 5 or 9. It makes no difference. The important thing is that problem 1, and also problem 1, you already renamed it. Okay, good. And run it. Compute. Don't worry about this warning. Okay, so if you look at the deformation, it's just compression. Basically compression. And this little piece, because of that, bad design there, is also going to bend. But if you can animate it, it's just basically compressing this. If you look at the von Mises stress, this is mostly in compression. It's a fairly uniform value. Okay, if you put the cursor there, it says 241, 241, 241 psi, etc., or actually 2140 psi. You see that? But when you get close to this end, the stress has become large, and particularly in that corner, it becomes very large. Okay. Yeah. Did I say 2000? I meant 241, 240 psi, somewhere down here in the blue area. 241. When you get down here, it gets large, and then of course this is 2104. This is a terrible mesh. I mean, basically, don't do this thing for designing a part. Uh, this is horrible mesh, horrible design. Okay, so save this. Let's make sure that we have everything in there. Notice that in my folder, I have uh, part here. Look, here's part problem 1, analysis of problem 1. Problem 2, analysis of problem 2. These indicators 1 and 2 here mean nothing. Okay, so that's pretty much it. What I suggest is you look at both videos for section 51 and 52 because there may be things that I've said there that I haven't said here, or the other way around for the people in the other group. In fact, you're better off looking at all videos for all 4 labs. Good luck, folks.